Hello everyone, this is Jason. This chapter, we will introduce parameter settings for 3x roughing. Through parameter settings, users can get the two paths that meet the machining requirements. Due to part of the parameters are same as them in 2x, so we will focus on the different parts in the following. First of all, I will introduce the limiting parameters. In the last chapter, we have introduced two different feature situations when generating roughing two paths, only with part and part with specific stock. Here we will introduce the containment types in the first case, only with the part feature. From this table you can see with different containment type, the two paths is different. If you want to generate the two paths in the specified area, you can add a profile, which class is contained. And next parameter is limit tool by stock. Is to control whether the two paths can pass the stock. From the images, you can see the differences intuitively. Then the next tab is reference tool. Is to define the reference tool, minimal rest height, and expand area, which is commonly used to optimize a rest roughing toolpath. Theoretically, when generating rest roughing toolpath, ZW3D will detect the rest material when material thicker than specified value. Here is 0.5. The material is highlighted in red, will be detected and removed, and the expand area will expand the detect area both sides based on the area defined by the mid-rest height, highlighted in red triangle region. And these are some application scenarios of reference tool, mid-rest height and expand area parameters. Reference tool is one of the ways to generate the rest roughing toolpath. For the other, please refer to the chapter Introduction of Rest Roughing. Normally, the mid-rest height and expand area parameters should be adjusted with the tolerance and surface thick. Then the next tab is checked. Is to check the machining devices like tables, clamps, holder to see if it will have a collision with workpiece to assure the safety. Check all of part. When define some surface of the part as the feature, it will check all parts related with this operation to avoid overcut toolpath. Check shortest tool to avoid the collision between the holder and the part. Here are the steps to calculate the shortest tool value. And here is the table to show you the other check parameters between tables, clamps, holder, and workpiece. Please check it carefully. Now, let's go to ZW3D to check the limiting parameters. First is the containment type, silhouettes and simple box. In the last chapter, we've learned that only with the part feature, ZW3D will use the maximum bounding as the stock. Actually, it has two situations. If the containment type is simple box, ZW3D will use the maximum bounding as the stock. If the containment type is silhouettes, ZW3D will use the silhouette bounding as the stock. Then, if you want to generate a two paths in specified area, you can add a profile, which class is contained. Let's check the effect. And next one is limit tool by stock. Through the two paths, we can know this parameter intuitively. One can pass stock boundary, while the other cannot. And next, reference tool. This option is used to generate rest roughing toolpaths. For example, this case, we use 10 mm flat end mill to do the roughing. Then, in the rest roughing operation, we can use it as reference tool. Then use a smaller tool, 4 mm ball end mill, to generate the rest roughing toolpath. And next will be the mid, rest height, and expand area parameters. First, we check this rest roughing toolpath. To better demonstrate the effect, we use ref operation to generate it and add a contained profile. Now the mid rest height is 0.6 and expand area is 1. If I change it to 0.5, that means ZW3D will detect more materials. So the toolpath will be like this. But obviously, the effect is not good in this case. The adjustment of these two parameters is different from case to case, and it is usually adjusted in conjunction with the tolerance and thick parameters. Next will be the check table. Firstly, we will introduce the check all of part and check shortest tool. This case, we select the surface as feature to generate the toolpath. If we want to check all the parts related with this operation to avoid overcut toolpath, we need to turn on this option. If not, ZW3D will not consider all parts. And to avoid collision between the holder and the part, ZW3D can also check the shortest tool length. Firstly, the precondition is the tool has a tool holder. Then right-click the Setup tab to call out the display settings. Then take minimum option under tool. Then we go to check parameters to turn on check shortest tool option. After calculation, we will have the shortest tool length value. Then next is the check options for tables, clamps, and holder. If turn them off, ZW3D will not consider these devices when generating toolpaths. To consider the clamp, you need to turn on the clamps option and set the relevant parameters like mill region and safe distance between tool and clamps. And also, you need to add the clamp to features. Then, this is the effect with check clamp and without check clamp. The same for the rest options. Check table. This is the effect without check table. Let's show the table and see the effect with check table. The toolpath lift up a little bit based on the safe distance and check holder. The same precondition is that the tool has a tool holder. The effect without check holder. The tool holder will have a collision with the part. and with check holder, the toolpath will consider the safe distance between the holder and the part. Next, we will move on to the tolerance and steps. It's used to define the tolerance and remaining surface thick of each operation, and the step over and step down value. For the tolerance and thick step over parameters, we have introduced into X parameter settings chapter, so we will not repeat here. For the step down, we have several different parameters here. Firstly, unlike 2x roughing, ZW3D uses absolute or percentage of fluid length to specify step down value. During the roughing toolpath, it uses number of cuts to specify the number of contour cuts between two roughing toolpaths. And when the number of cuts is specified, it uses the intact progress to define the cutting order between two roughing toolpaths. The images here can explain the meaning of the parameters clearly. Next is the non-uniform cuts. It's used to specify different step-down value in different regions. Now let's go to ZW3D. Here is the tolerance and thick parameters. We can set toolpath tolerance and the remaining materials of side surface and the surface. And the step over is same as the one in 2x. And the step down type, it has absolute and percentage of the fluid length. And the number of cuts here is to specify the number of contour cuts between two roughing toolpaths. For example, the step down in this case is 6 mm, and the number of cuts between the two roughing toolpaths is 2. If the Z intercut progress is top to bottom, the cutting order should be the first cut, the second cut, third cut, and fourth cut. The last parameter is non-uniform cuts. For example, this case, we want it to perform a smaller step-down value in the narrow area. So we can add a boundary point. The area above the point will use the step-down value, and the region below it will use region step-down value. Besides, you can also add multiple boundary points and manage them through the layer option here. Now we back to the PowerPoint and move to the next tab, Path Setting. In this tab, there will be the concept of filling cut and clean cut, shown as the images here. For the filling cut and clean cut direction, any means ZW3D will assign the direction to be climbed or conventional to get the zigzag pattern toolpath. Automatic means the clean cut direction follows the filling cut direction. And next is the path pattern guide. Is to define the guide of path pattern. And the next is the region order. Is to define the cutting sequence among regions. I've listed all the types in the PowerPoint. And next is the finish path. Is to define whether to detect the planar face on the part when roughing. Here is the two-pass effect. I will explain more in ZW3D. The last one will be the corner control. smooth, and deloop. Now let's go to ZW3D and check the path setting parameters. We have introduced the concept of filling and clean cut, and the direction of them can be set here. Then the next is the path pattern guide. Let's check the different effects. First is part. Then stock. Both stock and part. Last is profile. Offset number is 2. Next one, I'll show you the region order. Take X along for example. We can verify to check the order. Next is the finish pass. When in roughing, if the required cutting depth is not an integer multiple of step down, it will not generate 2 passes on each bottom. For example, this case, the depth is around 91.96 mm. The step down value is 10 mm here for demonstration. You see there is no 2 passes on the bottom. To solve this issue, we can use the flat detection option. First is whole flat level. That means it will generate a whole layer of 2 passes on the bottom. Just check the effect in ZW3D. And another option is flat region. It will only generate the 2 passes to remove the material on the flat area. Please note that the machining order is also different. We can check it through Verify. Then the last one is corner control. Normally, when the 2 pass turns direction, we want it has an arc to transfer smoothly to reduce the machine vibration. For the inner corners, we can use XY corner radius and percentage XY smoothing to control the corners on clean cut and filling cuts. And for the outer corners, the loop will be added to the tool pass when it turns direction. Now let's back to the PowerPoint. The last part of roughing parameter setting, link and lead, is used to define the short and long link type, short link limit, safe distance, plunge length, and so on. First, we need to know the segment of the tool pass. Normally is rapid down, then plunge to slow down, then slowly engage, then is the cutting tool pass. After cutting, it will retract, then rapid up. Traversal through the link tool pass to the next region and repeat. Next, we will introduce the link parameters. To distinguish short link and long link, we use the short link limit options. Then next one is the type of the long link and short link. For the common type to both optimized and clearance, they will recheck when linked to the next toolpath. And for the height of the link toolpath, optimized type will use the safe distance, while clearance type uses the clearance D plus safe distance. And the remaining three short link types on surface, step, and SP line, you can check it in this table. And the next, add lead to short link. As its name suggests, when the link type is short link, it can control whether to add lead to it. And percentage SP line elasticity is to define the curvatures for SP line link. Then is the engage parameters. The default color of the engage toolpath is blue. It's used to define the engage type and the corresponding parameters. It has 4 engage types: none, arc line, helical, and along toolpath. None means there is no engage toolpath, only rapid, plunge, then connected to the cut directly. Arc line, it has horizontal, vertical, and normal types, which means the arc will be generated on XY plane, YZ plane, or the normal direction of the machining surface. And the related parameters like arc radius, engage arc angle, engage length, please refer to this image. Next is the helical. The related parameters like engage ramp height, engage ramp angle, and the engage arc radius, please refer to these 2 images. Then the last one, along toolpath. Before cutting toolpath, there will be a ramp engage toolpath along the cutting toolpath. The related parameters like engage ramp angle, engage ramp height, please refer to this image. And safe ramp length, when using the non-center cutting tools for roughing, to ensure the materials can be removed without any collision, especially the center area of the tool. We need to set a safe length. In general, the minimum value is tool diameter minus twice the blade width. Please refer to this image to better understand this parameter. And recheck is almost the same as engage, so we are not going to repeat the introduction. After finishing the setting of engage, we can just copy the settings to recheck or vice versa. Now let's go to ZW3D and check these parameters. First is the short link limit. For example, the value here is 2, means if the absolute distance greater than 2 will be defined as long link. Less or equal to 2 will be defined as short link. So this case, this is the long link and these are short links. After that is the type of long link. We can switch to the left view. This is the type optimized. And clearance. We have already described the specific height values in the PowerPoint, so we won't repeat here. And for the short link, here are the effects. On surface, step, SP line, optimize, and clearance. and the effect of add lead to short link. And when the short link type is SP line, the percentage SP line elasticities can change the curvature for the SP line link. For example, change it to 100%. Then is the engage type, none, arc line. Helical. And along toolpaths. The related parameters has been described in the PowerPoint, so we won't repeat here. Once the engage parameters has been set, we can copy them to recheck directly, vice versa. Okay, that's all for the parameter settings in ZW3D 3X roughing. Thank you.